Hello, this is Sagacious, and in this video we'll be exploring relations between chance to cast Amplify damage on striking and mean physical damage inflicted per hit. I want to mention that I did a poll pertaining to my last video, which I asked people if they wanted additional content of the kind that was produced in that video. And overwhelmingly, about 69% of people said yes, but about 31% of people said no, and the most common reason was that people wanted the content either simplified or shorter in duration. As a result, in this video, and in all videos of this type hereafter, I'm going to first present a summary of the material discussed in the video. These summaries will be very brief and superficial. In this particular video, the summary will consist of a brief overview of the situation to which the equation pertains. I'll then discuss what the equation is. I'll show an example of how to use this equation. And lastly, we'll see if there are any interesting implications that we can infer from the equation. If you have further questions, such as how the equation was derived, or you just want to get a better understanding of the material, feel free to stay a while and listen, as there are timestamps below in the description of the video, so you can jump around at your own leisure. Please like and subscribe for additional content, and don't forget to drop a comment below if you have any other questions that aren't addressed in the video, or if you have a question that you would love to be explored in a future video. Without further ado, let's dive in. Alright, so let's start with the summary. What kind of situation does this equation pertain to? In this equation, we restrict our analysis to sequences of attacks that occur within a time interval tau, where tau is just the duration in seconds or frames, if you insist, of amplified damage. So just here's an example. Let's say we have some level of amplified damage and there's tau, some duration of time, and we start the clock at t equals 0 seconds, right? And here we have a hypothetical attack sequence where the Amazon goes in, attacks, and going in that animation length is the t here, right? And so there's one attack, it takes that time t, and so there are two attacks issued within this time tau, right? So we're just assuming that an attack sequence within the time tau. So in addition to attack sequences occurring within that interval tau, we have the following constraints, okay? So we're only talking about physical damage. Even though we could account for other damage types, that's not necessary. We assume no alternation of targets. That is, our character doesn't, attack multiple targets. We assume that the character does not alternate weapons when attacking, so no double swing, no frenzy. We're not trying to break an immunity to physical damage either. The target is not initially cursed with amplify damage, so we're starting basically an attack sequence on a target that is not initially affected by amplified damage. And lastly, we're assuming instances in which amplified damage is not overridden by anything else. So that, you don't have any other chance to cast another curse that would override it, unless, of course, it's overridden by itself from the same source. That's fine. All right, so let's dive into the equation now that we've discussed a brief overview of the situation to which this equation pertains. So for all applicable attack sequences occurring within time tau, again, by the applicable being in bold, we already specified a general idea of what we mean by that. We have that the mean analogous physical damage inflicted per hit is approximated by this equation, where D is the initial mean physical damage inflicted per hit by the character. That is the unmitigated, what you would calculate from a D2 damage calculator. R is the target's resistance to physical damage. P is the character's chance to cast amplified damage on hit. Tau is the duration of amplified damage. So it's worth noting that the reason, even though it doesn't appear in the equation, that we've kind of listed tau here, is really as a reminder that all of this is assumed to occur within the period of time of tau. That is, all of this is assumed to occur within the duration of amplified damage. And if you want to see why that's so important to this equation's applicability, just feel free to watch the rest of the video. N is the number of hits delivered within time tau. And D sub n bar is the analogous mean physical damage inflicted per hit. Now that we've discussed this equation, let's do an example. So in this example, let's say a character has a 50% chance to cast amplified damage on hit. The target is 20% resistant to physical damage. The character's unmitigated physical damage per hit varies from 1 to 2 inclusive. And the target hits twice. And again, all this occurs within time tau under the aforementioned conditions. So there are 16 possible cases. On the first hit, half of those, because we have a 50% chance to cast Amplify Damage, will trigger Amplify Damage. That is, it will cast it, right? So 8 of those is a yes, and the other 50%, in 8, it's a no. Now, we're assuming sufficiently random or pseudo-random number generation for our damage range, and it's only integers, so half of those yeses, half of those will be 1s and half will be 2s, right? And the same for no's. Half will be 1s, half will be 2s. Now, on the second hit, half of the half that are 1s, right? So those will be yeses or no's for the second hit. And then for each of those, we have a 1 or a 2, right? So this result, this probability tree, if you will, has this resulting table. Well, let's just look at the modifier that we would multiply the damage before its mitigation by, right? So in the first hit, they're all 0.8, right? Because none of these will actually get the benefits of Amplify Damage on that hit. So, you can see where you calculated here, 1 minus 0.2 minus, well, there's no, mitigation to that monster's resistance in this case. So that's just 1 minus 0.2, it's 0.8, right? That's how we got that. Okay, now, in the second case, well, half of those will be mitigated because half of the first hits did trigger Amplify Damage, right? So in that case, you can see that the resistance of the target will be reduced by 1, right? So 1 minus 0.2 minus 1, that's just 1.8. So the result here is that we have these mean damages, right, from each case. So this 1.3 is just the result of taking 1 times that modifier plus 1 times the next modifier in the second hit. And each of these are the case where on each hit we did 1 damage and dividing by 2 the number of hits. That gives you the mean damage over these hits, right? Now the mean of all these means is 1.575, right? So that's what our equation needs to produce if it's correct. So let's see, 50% chance, that's just P equals 0.5. That's just R equals 0.2, the resistance, right, to physical damage. The character's unmitigated physical, that's just D equal 1.5, right? If the range is 1 to 2, they're both sufficiently pseudo-randomly generated. 1 plus 2 divided by 2 is 3 halves, right? So that's 1.5. And there's 2 hits, so we have N equal 2, right? So let's plug this into our equation. 1.5 times 2 minus 0.2, etc. 1.575. So you get the same result, right? And that's pretty nice. That's a 5% increase in the mean physical damage inflicted per hit. So that's how to use this formula. And as it turns out, we can make some inferences from these equations about how much we can increase our mean physical damage per hit. That is, by what percentage. The vertical axis is a number that, when multiplied by 100, is the percentage increase to mean physical damage per hit. The horizontal axis is the resistance to physical damage of the target. As you can see, with increasing physical resistance of the target, you have exponentially increasing potential percentage increase in mean physical damage per hit inflicted by the character, with a vertical asymptote at physical immunity, as the equations are not defined in those instances. When the target's resistance to physical damage is 0, the maximum you could increase your mean physical damage per hit is 100%, right? Effectively doubling your mean physical damage per hit. And if, for example, the target's physical resistance were 95%, that would result in a potential 2,000% increase in mean physical damage inflicted per hit. That's insane. All right, well, that will conclude the summary. I'm now going to proceed with the rest of the video. So to get a better idea of the kind of situation we're talking about, we're going to revisit the initial video that I shared in the summary. So let's focus on the first iteration, that is the first attack, the first hit in that sequence. Well, what are the variables we're concerned with? Well, the initial amount of physical damage inflicted on that first hit is one of them. We're also interested in the target X's resistance to physical damage on that first hit, right? We're interested in the character's chance to cast Amplify Damage on the first hit. And we're interested in how much Amplify Damage reduces the target's resistance to physical damage. Now, why do we care about that? Well, because in some instances, obviously, say when breaking an immunity, it's not always a reduction of 100%. Right? When breaking an immunity, I think it operates at about 1/5 efficiency. So these are the things we're interested in. Using these, we want to actually compute the resulting amount of physical damage on that first hit. That is, we take the initial amount, We multiply it by some factor proportional to the target's resistance to physical damage, right? And we factor in whether or not amplified damage occurred on the first hit, and if it did, the amount that it reduced the target's resistances. So we're interested in D sub 1, R sub 1, P sub 1, and X sub 1. And then this outlined D sub 1 is the resulting amount of physical damage inflicted on that first hit. Whereas the non-outlined one is the initial, that is the unmitigated amount of physical damage inflicted on the first hit. And again, it's worth noting, I've bolded physical because we are assuming for now only physical damage. All right, so how do we calculate the resulting physical damage on the first hit? Well, we know it's going to involve the unmitigated physical damage dealt on that first hit that you would calculate from a D2 damage calculator. We'd multiply it by 1 minus the resistance on the first hit of the target normally. But since amplified damage may or may not have triggered, we'd have to subtract from the resistance of the target to physical damage on that first hit the amount of that physical resistance for the target that was reduced on the first hit by amplified damage. That's the X1, right? So we're going to multiply it by 1 minus, in parentheses, R1 minus X1. But of course, this will be only in the subset of cases in which amplified damage did trigger on the first hit. What about the cases where it didn't trigger? Well, then we're just subtracting 0 from R1, right? And in that case, that's just multiplied by the probability that it didn't occur, which would be 1 minus P1 if P1 is the chance that it did occur. And simplifying that, right, it's just the familiar 1 minus R1. And this gives us the sample space of possibilities, right? And simplifying just inside of that, so it's 1 minus R1 plus X1. We can factor out the D, that is the D sub 1. And then we can clean up the inside by distributing. You'll notice that the red and blue terms cancel. And so what's left is this equation. All right, so we have the resulting equation for the amount of physical damage inflicted on the first hit that results after the mitigation occurs, given all these factors. Well, we can argue by mathematical induction that assuming no additional constraints, this equation will be the same for any nth hit in the sequence. That is, for any nth hit in the sequence, the resulting amount of physical damage inflicted on the nth hit will be equal to this equation. So we have that for any nth hit in the sequence, the resulting amount of physical damage inflicted on that nth hit is given by this equation, where D sub n, that is the non-outlined in blue D sub n, that's the initial amount of physical damage inflicted on the nth hit. Now, why do we distinguish it with respect to n? Well, maybe it varies with n, where R sub n is the target X's resistance to physical damage on that nth hit. Again, maybe the physical resistance of the target varies with time. And so, it differs from one end to the next. Where P sub n is the character's chance to cast amplified damage on that nth hit. Again, it could vary with, if you're alternating between weapons, for example. And X sub n is the reduction to R sub n due to amplified damage on the nth hit, which again may vary between hits. For example, maybe the curse expires. Distinguishing each of these, with an N subscript is really acknowledging that many of these things can change across time and thus with respect to the hits, although the formula is the same. So there's another thing worth noting. In all this discussion, we haven't yet hitherto mentioned the probability to hit. And that's really because, as you'll see later on, we can account for that. For example, all you have to do is scale D accordingly. So you just take the probability to hit and you scale the initial amount of physical damage in accordance to that probability. And in the same sense, P sub n for any n could be scaled in accordance to the probability to hit on that nth hit. You would just have P sub n replaced with the conditional probability. That is the chance that you cast amplified damage given that you have hit. So, this equation already has the necessary variables to account for those nuances. Now, having it said that, there's another important concession that we should make here. This equation is an approximation, and there are a repository of reasons for which this concession is important to keep in mind. So here are some reasons that this equation should be understood as an approximation. So first, we haven't accounted for any rounding in the game. For example, there are many instances, such as when you're calculating the damage of a weapon that has enhanced damage on the weapon, that modifies the base weapon damage, where you have a decimal result, but the game rounds to a whole number, an integer, right? So that affects many calculations. We're not accounting for rollovers. That is, instances if and when there's a maximum number of digits for any computation, and when you exceed those numbers of digits, or that value, shall we say, the game will roll over to where you started the initial base value, and how much you roll over is proportional to that difference, etc. We're not accounting for those things that occur in the game, and thus will slightly change calculations. We're treating this data as though these are essentially real numbers, which means we're not treating this data set as though it's discrete, which is important. It would, in some instances, fundamentally change the systems of equations we use. So this third point is more conceptual, and it doesn't necessarily apply to this particular equation per se, but it's worth noting that if we get advanced, we'll be using differential equations. And very often solutions to differential equations are linear approximations. That is, they are linear approximations at a point within a neighborhood of that point of the solution curve. And so there's really systemic error in those approximations that is usually a result of the difficulty in solving explicitly for the solution. So, those are going to be constraints. So there's almost going to be a systemic error in our calculations. So having made this concession, let's kind of proceed. So now we're going to make some additional concessions, and while that will mean that we're looking at a smaller fraction of all possible cases, in that subset of cases, we then extend the power of our analysis. So what's the first simplification we're going to make? We're going to just get rid of that x sub n. We're going to assume only cases in which the amount of resistance reduced is 1, right? So in other words, we're just excluding instances in which we are breaking an immunity. So we're assuming that the Amplify damage reduces the target's resistance to physical damage by 100% or by 1, right? And since p sub n times 1 is just p sub n, that just disappears. And so we have the resulting simplified equation. The next major change we're going to make is that we're going to, instead of letting d sub n vary, we're just going to assume that that d sub n, that is the damage done on the nth hit that's unmitigated, is the unmitigated, or that is the the initial mean physical damage inflicted per hit. So we're letting that mean be constant across every hit. And so now we can notationally just shift that d sub n over to the left-hand side of the equation. We don't need to make a distinction between d sub n's. But you'll notice that by letting the initial mean physical damage inflicted per hit at this stage be constant, we haven't yet, from that assumption, demonstrated that the d sub n itself will be constant. It could still depend on n. And what's more, by making this change, we should note that the d sub n is now the resulting mean physical damage. That is, it's a mean inflicted on the nth hit because the d is now a mean. You could have argued that it was a mean, because of the variance in probability. But this makes it more clear that we're really talking about a mean at this point for d sub n. That is the resulting mean physical damage inflicted on the nth hit. So what's the next simplification we're going to make? Well, we're just going to think of sufficiently small intervals of time because generally speaking, a target's resistance to physical damage is not changing between hits or within small intervals of time, right? So we're going to therefore assume that R is constant. So the target X's resistance to physical damage is constant, so we're just going to call it R. There's no longer a need for a subscript to distinguish between hits. And so another caveat here that's important, but kind of inobvious, is this implies that we're not thinking about hitting multiple targets which may have different resistances. Sure, it's possible you could hit different targets with the same physical resistance, but then you have to worry about whether they're both in the radius of the Amplify damage, etc. So for the sake of simplicity, we're just going to assume that we're attacking the same target, and that's an implicit consequence of letting R be constant. It's not the only consequence, but it's just one thing we'll do for the sake of simplification. So we have the resulting simplified equation, right? And that's nice, because now we just have two constants. And the other thing we've allowed to vary between hits is the character's chance to cast Amplify damage on the nth hit. And the reasons why, will become clear later on. But for now, let's just take this equation and let's do some examples just to do a sanity check to see if it makes sense thus far. Okay, so if P sub n is 1, that is for any nth hit, if the probability on that nth hit to cast Amplify damage is 1, and the target's resistance to physical damage, which again we assume is constant, is 0, well then what should the expected mean damage for that nth hit be? Well, if we plug it in, it should be 2 times that damage. That makes sense, right? That's consistent with our intuition and what we would expect. Well, what about if the probability for any nth hit were just 0, right? Well, then plugging that in, we just get that the damage, the mean expected damage on that hit is just going to be D times 1 minus R, right? It's just reducing D proportionally to the target's resistance to physical damage. That makes sense. So that seems to check out. It seems legit. Okay, so now let's move on. You're probably wondering at this point, and I want to draw your attention to this, because this is where a lot of the nuance in this derivation lies. Why have we not yet made P sub n constant? That is, why are we still worried about the character's chance to cast amplify damage on the nth hit? And the reasons for this are inobvious, as to why we haven't made this change yet. But I'll motivate some questions that might start to make clear why we have yet to make such a substitution. So here's some important questions that we should consider before proceeding. So the first is, what if amplify damage expires? It's not clear yet how that question relates to the probability to cast amplify damage on a particular hit, that is on the nth hit in the sequence, but let's leave that question there for now. The next question we want to entertain is, if it triggers on hit n, does amplify damage reduce R, that is the target's resistance to physical damage, on hit n? That is, does the reduction in physical damage occur on the same hit when amplify damage triggers? That's an inobvious, or perhaps even innocuous, but actually substantive question, as we'll see later on. What if we alternate between weapons? Well, that's an obvious case in which P sub n could vary, right? So that kind of gives us some justification for why we haven't yet made that substitution. What if amplify damage is overridden? That's kind of important, although it's not clear how that relates to P sub n not yet being substituted for constant. Furthermore, what if the target was cursed by amplify damage before time t equals 0? That is, before we engage the target, what if it had already been affected by amplify damage? These are important questions, and they would really affect what we're trying to do here in our analysis, right? Because if the target was already affected by amplify damage, then you've already reduced its resistance, and the calculation is easy, right? All right, so we're going to start addressing these questions from the bottom up. So since the first question, would make it kind of trivial, right? Because if the target was already affected by amplify damage and you could kill it before its duration expired, the calculation for how that affects your damage is rather trivial. So we're going to assume that the target has not yet been cursed with amplify damage. That is, for all times t less than 0. And again, since your attack animation takes time, we're not worried about if it could be at time t equals 0, because your attack animation has a duration. So you're not going to apply that amplify damage at t equals 0 for it to affect that, etc. So for the next question, what if amplify damage is overridden? We're going to assume only cases where it is not overridden. So in other words, you're not playing in a party, right? You have no other sources of curses that could override it. The only exception we'll make here, okay, and this is important, is unless it's overridden by itself, we allow that. However, keep in mind, it must be from the same source, just for the sake of simplicity. All right, so there's no chance to cast Art of Curses, etc. So that kind of eliminates that concern. Okay, so what if we alternate weapons? For the sake of simplicity, we assume that we do not alternate weapons in these calculations. Okay, so no double swing, no frenzy. All right, then we have the remaining 2 questions. Let's start with the next one. So let's start with the question of, if amplify damage triggers on hit n, does amplify damage reduce the physical resistance of the target on that nth hit? That is, on the same hit that it triggers. This is actually an important question, right? Well, it turns out that if amplify damage triggers on hit n, right, then the physical resistance of the target, that is R, is actually reduced on hit n plus 1. Okay, more generally, okay, R is reduced on all hits m greater than n, delivered within its duration. Okay, so for every subsequent hit, and this is fundamental, very important for how we derive this equation, that for every subsequent hit during the duration of amplified damage under these assumptions, R will be reduced. Hence, it will be reduced on the n plus 1th hit if the duration allows. You can see, however, that these things are then related, right? What if it expires? Well, then that's not going to occur And piece of n is kind of how we determine the amount by which r is reduced. So we can see that these two questions are implicitly related to each other in an inobvious but a substantive way. Now, before I proceed, I'm going to demonstrate in-game that Amplify Damage does indeed not apply its reduction to physical resistance on the hit that it is cast. And I'll do this by having a test to make sure it's not just, for display purposes. The character in question has an axe that is modified to do an absorbent amount of damage, and so will kill any monster in one hit. However, what you'll see is we're going to choose a monster immune to physical damage, and in doing so, what will happen is the first hit will break that immunity, and then the second will allow us to kill the monster, as you'll see. If it were the case that Amplify Damage was applied on that hit, the monster would die on the same hit that Amplify Damage casts. And yet what you'll observe is that the first hit will cast, and only on the second hit do we actually kill the monster, as I'll now demonstrate. Okay, so if and when Amplify Damage triggers on some nth hit, it does not apply its reduction to the physical damage of the target on that hit. So having established that, we're also going to use this information from the Amazon Basin, that Amplify Damage happens to have a very good duration. Its base duration at level 1 being 8 seconds. Not bad. So we're going to use these two pieces of information, and from these we're going to be able to paint a picture that's going to help us make a calculation of the analogous mean damage per hit conferred from Amplify Damage. So we're going to let tau be the duration in seconds of Amplify Damage. So it's worth noting that tau can vary with respect to the level of Amplify Damage. The lowest value of tau being 8 seconds, which is still a long time in game during combat. And so because of that, we're going to hereafter restrict our analysis, in addition to all the aforementioned assumptions, to cases in which we have attack sequences occurring within time tau. Again, where time tau is the duration in seconds, or in frames if you prefer, of amplified damage. So something like this, right? We have tau there, and at time t equals 0, we begin the attack sequence. So here's one attack, right? And then here's another attack, right? So this is what we're thinking, in addition to all the other aforementioned assumptions here. All right, so let's imagine this increasing time axis starting at time t equals 0, right? And there's tau. Here's what's important is, we're imagining 2 hits just, to begin our analysis. It matters that the time in which these hits can be delivered is less than tau, which it is pictorially here. This flow chart, if you will, this probability tree is moving in the direction that is in the orientation of increasing time. And so here's hit 1, there's hit 2. So we're going to ask the following question for every hit. Was R reduced on this hit? So we're going to use the information we previously discerned. But in addition to asking whether or not Amplified Damage reduced the physical resistance of the target on a particular hit, we're going to ask for the same hit, was it triggered? That is, did it cast on that hit? So for the first hit in this sequence of 2 hits under, in time tau, in the case that it does trigger, right, because those are the 2 possibilities, in the case that it does trigger, we still won't have a reduction to resistance, as previously stated, because there was no previous hit per our initial assumptions. The target was not initially affected by Amplified Damage, so there was no reduction to physical resistance in that case. By the same reasoning, nor would there be a reduction when it didn't trigger. Okay, what about on the second hit? Well, this is where it gets interesting. If it does trigger on the second hit, there's still a reduction to the target's physical resistance because of the prior hit. It did trigger on the prior hit. And the same is true in the case of this branch of when it doesn't trigger, right? So each of these cases after it triggered on the first hit will indeed produce a reduction to the target's physical resistance to damage, right? In the case on the second hit after it fails the first to trigger, when it does trigger on the second hit, it will not have a reduction to the physical resistance of the target in that case. Nor will it happen to have a reduction to the physical resistance of the target in the event that both checks fail, right? And so let's just look at the probability on the second hit that we get a reduction to the target's physical resistance. So looking at these 2 boxes here, their sum, that is the probability that either occurs, is p squared plus p times 1 minus p, right? And that just simplifies to p. Whereas the chance on the second hit that it does not occur, that is the chance that either of those cases occurs, that's their sum, well, that's just 1 minus p. Right, so this is interesting because on the second hit, the chance that Amplify Damage does reduce the target's physical resistance, well, that's just proportional to the probability on the first hit that it triggered. And the chance that it doesn't is proportional to the probability on the subsequent, that is the first hit, that it did not trigger. So this is interesting to keep in mind. Let's see if we can establish, more of a clear pattern by looking at a case of 3 hits. Now again, we're letting time orientate forward, so the tree is moving in order of, in the orientation of increasing time. But all 3 hits are occurring within the time tau, some duration, depending on the level of Amplify Damage. Okay, so what we're going to do in this case is we're going to circle any instances on this tree of there being a reduction to the target's physical resistance due to Amplify Damage. So let's start just initially. There was no initial trigger by our assumption, right? The target is not assumed to begin with being in a state of being affected by Amplify Damage. So on the first hit, we can't circle any of these cases, whether yes or no, right? Neither of those are going to produce a reduction to the target's physical resistance. What about on the second hit? Well, again, on the prior hit, it did trigger in the cases on the left-hand side of that branch, right? And so these 2 cases circled here, it will be a reduction on the second hit. But the 2 on the other side, right, the right-hand side, there will not be any such reduction. What about on the third hit? Well, on the third hit, all of these cases will have the reduction because it triggered on the first hit, right? And independent of what happens in subsequent hits thereafter regarding its triggering, whether it's overridden or not, the duration has yet to expire either from the first, or it has just been recast and still has yet to expire from the second iteration, right? So either way, on this left-hand side of the tree, we have a reduction to the physical resistance of the target. And notice that on the right-hand side of the tree, right, because on the subsequent hit, that is the second hit, there was a trigger, we do have a reduction on that left-hand side of that branch, right? So only in the case, again, where we've had successive failure, do we actually have no such reduction. And that's not a coincidence. What we're really asking here was there at least one instance prior to this step at which Amplify Damage was cast? And the only case in which that will not be the case is when we have 3 successive failures, right? When all 3 of the prior hits failed to trigger it, then and only then, because again, the duration has yet to expire. We're still within the interval of time tau, so that means that the question really has been simplified. We don't have to worry about the expiration of the curse. All we really need to ask is, has it triggered yet? And the only case in which we will not therefore get on any nth step of this ladder, if you will, a reduction to the target's physical resistance is if we've had successive failures, right? So really for any nth step, you could prove by mathematical induction that the chance that you don't get a reduction to the target's physical resistance on that step, that is on that nth hit, that's just the cumulative probability that all n-1 hits, that of all prior hits have failed to trigger Amplify Damage. But that implies something interesting, right? Because now we define P sub n to be the character's chance to cast Amplify Damage on the nth hit, but now we see the counterintuitive mathematical implication, that we could prove by mathematical induction that for any nth hit, the probability that we get a reduction on that hit, that is P sub n, is actually equal to the probability that we had at least one subsequent success. That is the probability that at least one of the n-1 hits triggered Amplify Damage. Right, and so then we can just let P be constant. We can just let P sub n be 1 minus P to the n-1th power, where n is the number of hits, right? And then P is just a constant now. P is the character's chance for any particular hit to cast Amplify Damage on striking or on hit. So we have a nice simplification. Now we have sufficient grounds to make the substitution given these constraints. And let's just check that this, is consistent with what we've observed thus far, right? So on the initial hit, we should never have a chance to get a reduction to the target's physical resistance. Let's see if that's true, right? So P sub 1, that's just going to be 0, right? Substituting n equal 1, that checks out. So we cannot have a reduction to the target's physical resistance on the first hit. What about the second hit? So we saw from the previous tree that we should have a probability proportional to P, right? That is the chance that the first hit actually triggered amplified damage. And that's exactly what we have. You plug in n equal 2, and you just see that P sub 2 is equal to P, right? All right, so keeping this in mind, we can now make a revision to the previous equation pertaining to the mean physical damage inflicted on the nth hit. So let's do that. All right, so this is what we had previously, and now let's make the change. For any applicable attack sequences occurring within time tau, right, we're going to define P to be a character's chance to cast amplify damage on hit. We're going to let P be constant. We're going to say that P sub n, right, will now vary in accordance to the following equation. It will be proportional to 1 minus P to the n minus 1th power. We're just going to note tau here as the duration of amplified damage, just to make sure that's clear. And n, of course, is then defined as the number of hits delivered within time tau. And it should be understood that all this is occurring within the aforementioned constraints, previously discussed. All right, so we now have a generalized formula for the resulting mean physical damage inflicted for any nth hit. All right, so now let's define bold d sub n to be the resulting mean cumulative physical damage inflicted by n hits within time tau. So let's be clear about what we mean here. Notice this one's bolded. I don't want this to be confused with the mean damage inflicted on any particular hit. This is the cumulative mean damage, if you will, after n hits within time tau. Because by calculating this cumulative mean physical damage inflicted after n hits within time tau, we can divide by the number of hits to get an analogous mean physical damage per hit given the number of hits within time tau conferred from the chance to cast amplified damage on striking, right? So that's the idea here. So that's what this bold d sub n is doing. That's why we care about this one. So let's start by calculating bold d sub 1, right? That's just going to be d sub 1 because it's cumulative and there's only been one hit. So that is just the mean physical damage inflicted on the first hit, right? Or after one hit, if you will, right? So just plugging in that formula for the previous equation. And we're not going to substitute P sub n just quite yet. We could, but I think why we're not making that substitution, that'll be clear later on. Okay, and so this is just d times 1 minus r plus P sub 1. And it'll become, again, clear later on why we care about putting it in this particular form. All right, let's now do d sub 2, right? That's just the cumulative damage after 2 hits in time tau. Well, that's just going to be the mean physical damage inflicted, on the first hit plus the mean physical damage inflicted on the second hit, right? And again, these are within time tau, right? Let's just substitute their definitions based on the previous equation that we defined, right? Make a simplification by factoring out that common factor of d and then simplifying further. And you notice a common factor of 2 there, 2 minus 2r. So factor out the 2. And now it should become pretty clear, the pattern, right? So we have, by mathematical induction, right, you can see that it's just going to be d sub n, that is the cumulative mean physical damage, right, from n hits in time tau. It's just going to be d times n times 1 minus r plus p1 plus da-da-da-da plus pn, right? And now you can see why we haven't yet substituted P sub n, or for any particular n, into the equation. Or perhaps that will be more clear later on. All right, so we want the mean physical damage per hit that's analogous to this increased damage. So now what we're going to do is we're going to divide this cumulative damage, given these number of hits in time tau, by the number of hits. And that's going to give us the analogous mean physical damage per hit. So let's do that, right? We substitute the definition from the cumulative mean physical damage given these hits. And we can just, of course, simplify by separating the numerator, right? And notice that the n's on the left-hand side cancel, so you just have 1 minus r. And so what we're left with is just p1 plus, da-da-da, all the way up to pn divided by n, right? We're left with that quotient. Okay, so this is kind of why we haven't yet made this substitution for the p sub n's in general, right? Because we know that any particular p sub n is just 1 minus p to the n minus 1th power, right? And so given that, right, let's start plugging those in now. So we're just going to, for the p sub 1, so the p1, pn, p2, etc., right? So for p1, p2, etc., n, we'll just plug in the corresponding formula for p sub n, for all n, right? So let's do that, and that's the resulting equation. Now, you'll notice that there are n such ones, right? Because we plugged in n of them. We counted up from 0 all the way to n minus 1. So that's just going to be an n minus, since we took out all the ones, each of those. So minus 1 minus p to the 0, minus minus 1 minus p to the n minus 1, right? So there are n 1 minus p terms, right? Starting at the power 0 all the way up to the n minus 1th power, right? Well, let's just separate the numerator of that fraction, right? So we've got plus n over n minus, so we factor out the negative sign from all those minuses, and now we just have a summation, right, of all the terms of 1 minus p, and that's just, 1 minus p to the 0th power plus plus 1 minus p to the n minus 1th power, right? N over n is just 1, right? And, that's pretty obvious. So we just move that 1, and we have 2 minus r minus, and then we just have this summation, right? So we can put that in summation notation. So let's do that, right? So it's just 2 minus r minus 1 over n times, the summation is k varies from 0 to n minus 1 of 1 minus p to the k power, right? K is just indexing those terms of 1 minus p. All right, so now let's make an assumption that p is greater than 0 and less than 1. And the reason we want to do this is as follows, because this sum, this partial sum, can be written as 1 minus p to the nth power divided by p, right? And so knowing that p is greater than 0, well, that's going to allow us to know that that denominator there is non-zero, right? And that tells us that this substitution makes sense. So let's substitute this, right? So we have, if p is greater than 0 and less than 1, that we can make this substitution, right? So, all right, so let's factor out a negative sign from the numerator of that fraction that we just made the substitution with for the summation. Okay, so then we just have that d sub n bar is approximately equal to d times 2 minus r plus that fraction. That's pretty clean. All right, so we have our equation for the analogous mean physical damage inflicted per hit under these constraints, right? That is, for all applicable attack sequences occurring within time tau, we have that the analogous mean physical damage inflicted per hit, that is d sub n bar, is roughly equal to this equation, where d is the initial mean physical damage inflicted per hit, which is constant, r is the target, x is resistance to physical damage, again, constant, p is the character's chance to cast amplify damage on any particular hit, again, constant, tau is the duration of amplify damage, and n is the number of hits delivered within time tau. It goes without saying that we need to keep in mind all the previous assumptions building up to this equation that we made. So all of those still apply. We're not alternating targets, etc. To kind of capture the intuition in a nutshell of what kind of situations we're talking about, just refer to the initial video that I showed you. That's essentially what we mean. We're just talking about attacking one target at a time consistently, and just remember that we're doing so within the duration tau of amplified damage, and we're starting at time t equals 0. All right, so now that we have this equation, let's do some examples. So in this first example, which again I gave in the summary of this video, we assume that a character has a 50% chance to cast amplified damage on any particular hit. We suppose that the target is 20% resistant to physical damage, that the character's unmitigated physical damage per hit varies from 1 and 2 inclusive, and that the character hits the target twice within time tau, where tau again is the assumed duration of amplified damage. All right, so there are 16 cases. And as we previously discussed in the summary, half of those, because we have a 50% chance to cast amplified damage on hit, that is 8, there's going to be successes in triggering amplified damage, and the other half, the other 8, will be failures, right? So yes, no. And then half of those yeses, because we're assuming a sufficiently pseudo-random number generation success between 2 and only 2 integers, 1 and 2 for damage range, well, half of those will be 1s, and half of those successes will be 2s. That is, in half the cases we succeed in triggering amplified damage, we'll get a damage of 1 that we inflict, and in the other half of those cases in which we succeed in triggering Amplify damage, we get a 2 in the damage we inflict. And, the same applies for the failures. On the second hit, again, so half of those cases in which we did 1 damage upon success on the first hit, well, half of those will be on the second hit successes, and the other half of those will be failures. And of those successes, we're going to do 1 or 2 damage, and of those failures, we're going to do 1 or 2 damage, etc. Right? So you have the resulting table from the probability tree. We can make now a substitution on the first hit. We now know, right? So we understand that on the first hit, we will have no reduction to the target's resistance to physical damage. And so we already know the modifier we're going to be multiplying the unmitigated damage we would inflict on that hit, right? It's going to be 0.8 for all cases. Because again, we assume under these constraints, the target was not initially affected by Amplify damage. Right, and so this is just showing how you can calculate the 0.8. It's just 1 minus the target's resistance to physical damage. So in the case of the second hit, we know again that this chance that there's a reduction on that second hit is proportional to the probability of success on the first hit, right? So the first 8 cases succeeded, and so we know that we have, you can show how to calculate it, right? You're just taking the resistance of the monster minus 1 because it's reduced. We're not assuming we're breaking an immunity. So it's just 1 minus, in parentheses, 0.2 minus 1. That's just 1.8. So the first 8 cases where we had a success with the prior hit, we will have a reduction. And, in the other 8 cases, 9 through 16, we will not, right? We'll still have a failure. So we have the resulting modifiers on hit 2 to the damage we would have dealt on that hit. All right, so now we have these numbers. And what they are is they're the mean damage that we would have inflicted over the 2 hits in each of the cases, right? So in this first row that I've highlighted, what we're saying is our unmitigated damage would have rolled a 1. And in the first hit, we would have had a modifier of 0.8. And in the second hit, we have a modifier of 1.8, right? So you just add these up. That's the cumulative damage in this case after the 2 hits, and you divide by the number of hits. That's 2. That gives you the mean physical damage inflicted in this case per hit. Now, the mean of all of these means is 1.575, right? So if our equation is correct, then plugging in these variables, we should be able to get this result without having to, bother with all this tedium. So let's do that. Well, if the chance to cast Amplify damage is 50%, then we just have P equal to 0.5 for any particular hit, right? Again, it's assumed to be constant. All right, and the physical resistance, that's just R equals 0.2. If our physical damage inflicted per hit varies from 1 to 2 inclusive, then 1 plus 2 divided by 2, right, the mean, that's just 1.5. So D is 1.5. And we hit 2 times, so N equals 2. So let's plug this into our equation, right? So we have D sub 2 bar, right? The analogous mean physical damage per hit is given by this equation. And we get 1.575, right? And it's worth noting that this is a 5% increase in the mean mitigated, that is resulting physical damage we would have otherwise dealt to the target without a chance to cast Amplify damage. All right, let's do a second example. We'll keep the variables the same as in the previous example, so a 50% chance for the character to cast Amplify damage on hit. The target will again be 20% resistant to physical damage, and we'll assume again that the character's unmitigated physical damage per hit varies from 1 to 2 inclusive. Let's just change this though. The target hits 3 times within time tau rather than 2 times. Okay, so those are our variables. Let's plug them in. So D sub 3 bar will then be equal to 1.825. And believe it or not, if you go through the probability tree and calculate it, you'll get exactly that amount for the mean value. So this is correct. In this case, notice that we have a 21.6 repeated percent increase in what we would otherwise have done in mean physical damage inflicted per hit. So that's pretty nice. All right, so we've done a lot of talking in these examples about percentage increases to the mean physical damage inflicted per hit that result from a chance to cast Amplify damage on striking. So let's see if we can put an upper and lower bound on this to see the variance in what we might get in percentage increase to mean physical damage inflicted per hit as a result of having a chance to cast Amplify damage on striking. So let's start with the upper bound. So let's assume again the constraints of our equation that P is greater than 0 and less than 1. We saw in the previous 2 examples that we had a larger percentage increase in the mean physical damage inflicted per hit. So it stands to reason that if we let n go to infinity, we should get an idea of the upper bound, right? So let's do that. Let's let n approach infinity. And the limit as n approaches infinity of d sub n bar, well, we can put that limit inside because those two, the d, the 2, and the r, those are just constants, right? And so that limit, that fraction there is just going to 0, right? So this really is d times 2 minus r, right? It essentially, as n approaches infinity. But notice, to let n approach infinity, we're imagining, because of our assumption that all n are occurring within time tau, we're essentially imagining an infinite duration in theory, right? We're saying if you could just start attacking and it was always just a question of has it gone off yet? Has it gone off yet? Essentially, you're getting closer and closer to the question of, is the target's resistance just permanently reduced by Amplify damage from the beginning? Essentially, it's the same as if you just were able to attack a monster from the get-go, being affected by the reduced resistance from Amplify damage, and you could kill it within that duration. Essentially, it's analogous to that. So that's the upper bound, right? And just to demonstrate that it is the upper bound of our analogous equation. So let's just assume that, again, p is greater than 0, less than 1, and d is greater than 0. And that's just because to show that this is indeed bounded in this way, that there's this approximation, we're going to have to make a division by d, right? And we don't want to divide by 0. So just for the sake of simplicity, d is greater than 0, which again makes sense because we're assuming we're damaging a target, right? That's the whole point of applying Amplify damage, to apply the physical damage to that target. Okay, so we divide by d, we just have 2 minus r. We can subtract 2 minus r from both sides of that equation, right? And then we can just multiply both sides of the equation by n times p. That's fine. And so we just have 1 minus p to the n minus 1 is less than 0. We can add 1 to both sides. We just have 1 minus p to the n is less than 1. But if we had any further doubts about that, whether that would be true, we can just take the natural log of both sides. The natural log of 1 is 0, right? And by the properties of logarithms, we can factor that n out of the natural log of 1 minus p, right? So we just have n times the natural log of 1 minus p is less than 1. Well, we know that n is greater than or equal to 1. We're not considering n equals 0, 0 hits, in which case the only way that that's going to be less than 0, since n is greater than or equal to 1, is that we need, therefore, the natural log of 1 minus p to be less than 1, which implies that 1 minus p needs to be less than e to the 0, which is just equal to 1, right? So we need 1 minus p less than 1, subtract 1 from both sides of the equation. We need the opposite of p to be less than 0, and so we just need that p is greater than 0. So in other words, the assumption that this is an upper bound for that approximation requires that p is greater than 0, which again is consistent with our constraints and our assumptions. So there we have it. This approximation is bounded above by d times 2 minus r. That's the upper bound of what we could expect for the analogous mean physical damage inflicted per hit by the character, resulting from a chance to cast Amplify damage on striking. So what about the lower bound? We understood from our tests in-game that the first hit will never give us the reduction to resistances from Amplify damage, and by assumption, we're not starting with a monster that's afflicted or cursed by Amplify damage, so there's no reduction to its innate resistances. So again, assuming the constraints of our equation that we've derived, let's just plug in d sub 1, because that will be the case where we can never have an increase, and so theoretically it should be the lower bound, right? So let's just see. So d sub 1, of course, plugging in our equation, is approximately given, right? And again, the approximate is just a concession to, the fact that we're not accounting for rounding, rollovers, etc., right? I don't want to confuse people here. D sub 1 bar is just 2 minus r plus that quotient, cancellations of 1, so it's just minus p over p, which is just 1, right? And 2 minus 1 indeed, right? D sub 1 bar is just approximated by d times, 1 minus r. It's essentially as if we had no chance to cast Amplify damage, because, right, and this is consistent with what we found. We don't get a reduction to the target's resistance, right? So that seems to be the floor of this. But let's prove that, because who knows, right? Better that we demonstrate this is the floor rather than assume it, right? So let's just see if this is indeed true, that our approximation for the equation is greater than or equal to this. So let's see if this is indeed a floor for our approximation. So we're going to assume again the constraints of our equation, and again, since we're dividing by d, that d is greater than 0. And what we want to see is whether or not it really is true that for all, in any case, that for all n, for all r, for all p, we're never going to have a situation where we lose damage. We can only at least equal or do better. That's the idea, right? And we're checking to make sure this is indeed the floor, so to speak. So let's divide out d, and then we can subtract 1 minus r from both sides of the equation. So we have 1 plus this quotient needs to be greater than or equal to 0, right? And so we can multiply both sides of this equation by np, that's fine. All right, and then distributing the np inside of those parentheses on the left-hand side, that's np plus 1 minus p to the nth power minus 1 needs to be greater than or equal to 0. That's the implication here. So in other words, the assumption that this is the floor for our approximation of the mean analogous damage inflicted per hit resulting from a chance to cast amplify damage requires that this equation be satisfied. That is, adding 1 to both sides of that equation and subtracting np, we need that 1 minus p to the nth is greater than or equal to 1 minus np for all np, right? That's what we need. So the assumption that that is the floor requires that that bottom equation, that is 1 minus p to the nth, is greater than or equal to 1 minus np. And to make sure nobody's confused, we're not saying that d sub n bar is suddenly equal. We've used an equal sign that greater than or equal to that. We're saying the approximation has this floor. I want that to be clear. And in the same sense, when we had less than, we're saying the approximation was less than, not d sub n bar itself. We're making these inferences about this particular approximation. All right, so let's show that this is indeed true for all n and p under our assumptions. Okay, so let's start with the basis case. We're going to prove this by mathematical induction, right? So plugging in n equal 1, we obviously have that 1 minus p is greater than or equal to 1 minus p. So that checks out. Now we need, now that we've had the basis case, let's prove this for any n. So assume that 1 minus p to the nth is greater than or equal to 1 minus n to the p. If this, if this succeeds, we need to then successfully show that 1 minus p to the n plus 1 is greater than or equal to 1 minus n plus 1 times p. That's what we need to show. Well, 1 minus p to the n plus 1, that's just 1 minus p to the n times 1 minus p to the first, right? By the properties of exponents. And of course, that we already know by our inductive hypothesis, right? That 1 minus p to the n is greater than or equal to 1 minus np. So we can, observe therefore that that product, 1 minus p to the nth times 1 minus p, is greater than or equal to 1 minus np times 1 minus p. Right? So let's expand that product. And then let's factor out the p. Okay, let's then factor out the n. And you'll notice that, again, 1 minus p, because p is between 0 and 1, is going to be less than 1, which means we're not multiplying p by all of n. It's something smaller than n, for all n greater than or equal to 1, right? And since we're subtracting that, that means that value is going to be a smaller amount subtracted than if we had, multiplied by the whole n plus 1, rather than a portion of n plus 1, if you will. So that's going to be less negative for sufficiently large n than 1 minus p times n plus 1 would be, which means that for sufficiently large n, right, n greater than or equal to 1, we have that 1 minus p times n times 1 minus p plus 1, close parenthesis, that's greater than or equal to 1 minus p times n plus 1. Right, and thus we have that 1 minus p to the n plus 1, that's greater than or equal to, well, the order of the terms doesn't matter by commutativity of real numbers, right? So that's greater than or equal to 1 minus n plus 1 times p, which is what we wanted to show. So indeed, this is a floor for all np under the constraints of our assumed equation, right? So we now have that assuming that 0 is less than p less than 1 and our d is greater than 0, we have upper and lower bounds for this approximation of d sub n bar. That is the analogous mean physical damage inflicted per hit by the character as a result of that character having a chance to trigger amplify damage on striking. And notice that we're assuming that the target's resistance to physical damage is greater than or equal to 0, but less than 1. And the reason we're doing this is because we're going to derive an equation for assessing percentage increases in the mean analogous physical damage per hit conferred by a chance to cast amplify damage on striking. And so we're going to be dividing by 1 minus r, and we don't want to be dividing by 0. And so if we let r be greater than or equal to 0 but less than 1, that ensures we can't do that because we have a term of 1 minus r in the division. And d is greater than 0 again, so that when we make this division, we're not dividing by 0. So let's do that. Okay, and so, dividing by D times 1 minus R. That is the damage, essentially the lower bound, if you will, right? The floor, what we would have initially done without a chance to cast Amplify Damage on striking. Well, dividing it by itself, that's just 1, right? And dividing D times 2 minus R by D times 1 minus R, that just results in the quotient 2 minus R divided by 1 minus R, right? And so we see that subtracting 1 from all sides of the inequality, right? That basically gives us the percentage increase in mean physical damage inflicted per hit conferred by a chance to cast Amplify Damage on striking, right? And so we see it's greater than or equal to 0 in all cases, and it's less, and this approximation is less than 2 minus R divided by 1 minus R minus 1, right? So let's graph that so we can kind of infer graphically what's going on here. All right, so again, given our assumptions, we have P is greater than 0 and less than 1. R can be greater than or equal to 0, but it must be less than 1. And D is greater than 0. And again, R being less than 1 really makes sense because we did say we're not thinking about breaking physical immunity, right? So in other words, R is not equal to 1. Right, so the vertical axis is an amount that when multiplied by 100 gives the percentage increase in mean physical damage per hit conferred by a chance to cast Amplify Damage on striking. The horizontal axis is the target's resistance to physical damage. The shaded region of the graph tells us the variance that can occur. That is, for any particular resistance, we can either have 0% or we can have up to the dotted line. So as we can see from this graph, which is consistent with our intuition, if the target had 0 physical resistance, then we can have up to a 100% increase in mean physical damage per hit. But notice that we get exponential increases in the percentage of mean physical damage conferred per hit as a result of having a chance to cast Amplify Damage as the physical resistance of the target increases, with a vertical asymptote at R equal 1. Right, so this is interesting because, for example, if the target had 95% physical resistance, then the result would be a 2,000% increase in the mean physical damage inflicted per hit. All right, so having said that, this concludes the video. Please like and subscribe for additional content, and please feel free to comment below.